right? It's 5:30.
Yes.
Right?
Yes.
Thanks for coming. I'm glad to see so many people. Thanks for staying. I understand it's like the last presentation on the conference. I'll try to be quick. I don't think we're going to use the whole hour and 15 minutes extra. I think I will speak for about 20-25 minutes. Then I will give you a practical presentation of what I mean by this chatbot, and then I will expect questions, which I believe you will have. So basically, in a nutshell, that's what I want to say. So the user interfaces in general is not a perfect solution for small microservices, which provide some service, some functionality to technically experienced users. I'm talking about programmers, developers, architects, whatever. So the UI this is the summary of the next hour of my talk. UI sucks, and chatbot is a perfect replacement for the UI. And I'll show you. I guess you're technical people here, so I will be, I'll try to speak. I'll try to be as technical as possible. So this is the simple diagram. This is the only diagram in this presentation. Is it clear? Do you see it? Okay, good. So on the left side, that's user. It's me who's going to use some service. In our case, I'm going to talk about, let's say, the service which is on the right side. It's a microservice or something which helps us to manipulate some resources. Later, I will show you the practical example, and that's going to be a manager of a number of servers, a manager of a number of Docker containers. But it's not really important. What's important now is that the user who stays on the left wants to do something with that service on the right. And the traditional approach to do that is like this. So I'm the user, I'm making a request, an HTTP request or whatever, I'm using the browser. I'm talking to the UI. The UI is the piece of the code or the component inside the service. And then the service gets this request and does something with the database and with some assets. In our case, there are like Docker containers or some machines, whatever. So this is a traditional way of how these microservices work. And this is what I think is not really perfect and can be replaced by this approach. On this diagram, you see that the service and the user are decoupled now. The user is not talking to the service directly. Instead, the user is talking to some message hub, which can be Slack, which can be IRC, or which can be, in our cases, GitHub. So it's a place where two components, two parties can communicate. One party is the user, another party is the server. So instead of me as a user being a client of this service and talking to this service, instead I go to some messaging platform, I post some information there, and I get a response from the server, which is, in this case, is a chatbot. So you probably know what chatbot is. When you go to some Slack channel, you may see some bots which are replying to your messages and giving some information. I think that's what I'm trying to present, that the future of microservices, the better architecture for microservices is to design them as chatbots. And why? I'll give you a few practical reasons right now. But that's what the concept is about. So instead of being a standalone solution which has an UI, which has an HTTP interface where the clients have to connect and to get something, the service becomes a client itself. So in this case, the service is a client of this messaging hub. So now, as you see the arrows are coming from the user up and from the service up. They both are clients of some messaging hub, of the Slack, for example, or whatever it is. In this case, we have a client and the server. This is from the past. This is how we were doing, this is how it was before. And now, when we have these perfect messaging platforms, messaging hubs like Slack, like GitHub, and a few others, we can use a new architecture, which will give us a number of benefits, which we'll discuss right now. So, is it clear? I mean, technically, how it works, like what I'm trying to present. All right. So basically, this is a summary. So we have the client versus the server. Before our microservice was a server serving requests, and now it's a client for the messaging platform. It's a very important difference, which actually will give us 6 benefits. So I'm going to summarize 6 important elements, and that's going to be it. So that's my presentation about. I'll show you 6 important things which this solution gives us, And then I'll show you practical example how we implemented that and how it works for a year and a half for us right now, and the service is being used for over 300 users on GitHub. So it's not just theoretical idea, it's also a practical one. So the reason number one, the first reason is why it's good, why this being a client is better than being a server, is that you don't need to be fast. Because now you're not serving requests. You're not expected, nobody is expecting you to give answers in a few milliseconds, which people usually expect when there's a microservice. So they expect to make a connection to the microservice and then get an answer in 20 milliseconds, or maybe like up to 100 milliseconds. But they would not expect, they would not like your service if you give an answer in 2 seconds. That would be the microservice, which basically is really badly designed. But in this case, because you're a client now, nobody cares about your speed anymore, because in the chat, we don't really expect these bots to give us answers in a few milliseconds. We just post a question to Slack, and okay, 1 second, 2 seconds, 5 seconds, we get an answer. So the problem of the speed and how fast it should be done, now we put this problem on the client's shoulders. So now the client will not expect us to be fast. So, which is good for the design of the microservice, which is easier to design a microservice when we don't need to be fast. It's just the first advantage, the first thing we as architects of this solution will get. And in our case, in our practical chatbot, we had that too, because we are dealing with servers which are staying somewhere, and we need to connect to them, we need to get some information from them. This is all SSH tunnels, and it's not really fast. So it's really difficult to make, if you know, our service is kind of similar to Travis, which is probably, the continuous integration online solution. And when you go to services like Travis, and you want, for example, you want to see the log of what's going on, you open the web page, and then there is JavaScript loading some information, and it takes some time. So it's not like immediate. You can't open the page and then immediately see the logs from the server. Because when you go to the page, they need to connect to the machine, they need to download the data, it takes time. And that's why they need to develop some JavaScript, they need to somehow keep you waiting on the web page while they're going to some extra resources, databases, servers, containers, whatever, over the network. In our case, it's not really important because nobody is expecting us to give answers immediately, to stay on the web page, because we communicate through the messaging platform. You post a question, we give you an answer. When? In a few seconds, or maybe half a minute sometimes. It's not really critical. So for the architecturing perspective, you don't need to be fast. It's a huge gain for architects. The second reason is, there are 6 reasons in total. The second reason is you don't need to look cute anymore, which means that there are no web pages anymore. People don't see you when they talk to you on Slack or on GitHub. I mean, they're just messages. So you don't need to design your website to look nice, to attract your users. All you need to do is get the system to work, to do what it promises to do. But you don't need to worry about the colors of your buttons and how they're allocated, which is a typical problem for small companies who design some microservices, which are useful, but they look ugly, and that's why they never get to the market. Because now the demand for the interface is quite high. We have really beautiful websites and really beautiful web services, and people will not use your service if you don't design it in perfectly graphically, which is also difficult for small companies, small web services. In this case, you don't care at all. You don't have a web interface. All you have is just my name, the name of the bot is, ABC, talk to me on Slack, ask me a question, I'll give you an answer. So there's no UI at all, which means that people will not complain about the UI. So you don't need to look cute. That's my basic point. This is the second advantage for me as an architect of a web service. I was creating this, I came to this whole idea of this chatbot from a practical perspective. I needed to create a solution for my own needs. We have a team of programmers, I have a team of programmers around me, so we needed a continuous delivery solution which will manage these Docker containers, etc. But I didn't have a lot of time to design it in a perfect way. So that's why I jumped into this idea, and it was just perfect for me, because it was like one developer, just 1 week of work. I don't have time for the perfect UI, but I don't need it now. I just created a bot which just talks to you, and nobody knows what's the real design. There is no real design. That's the second question, second advantage. which I think is, again, important for architects. It's maybe not so important for big companies who really have resources and funds to make it perfect. But for us, I mean, for people who are startup founders or just making something for something simple and they want to put it on the market, this is an very critical benefit. Number 3, it is much easier to scale. Why it's much easier to scale? Because the service, the web service, the microservice is now a client, not a server. So it's much easier to create 15 clients talking to the same messaging platform and somehow synchronizing their parallel work, instead of making a server to handle multiple requests at the same time on 15 machines. It's like different problem. It's different scale of the problem. Just creating 3 different servers and they will talk. We just need to synchronize our data on some database. That's it. We're done. We just copy 5 different. I don't know. We created this in Java, so we just copy this 5 different Heroku. We just start 5 or 3 Heroku machines or Amazon machines, and that's it. And they basically work with the same central database. We use Amazon DynamoDB, so we just 3 instances connect to one DynamoDB, to a number of DynamoDB tables, and that's it. The problem is solved. I mean, we don't need to worry too much about how to handle huge traffic in parallel. When people are coming to us incoming, we need to somehow load balance, do the load balancing, make sure this traffic is not lost, make sure that one server is perfectly loaded while the other one is idle. You know this problem, which is really typical when the web service or microservice or web system just answering requests and being a server. In our case, like I mentioned before, it's not a server anymore, it's a client. And being a client gives us a huge advantage in this area. It allows us to be easily scalable. Horizontally, vertically, we can make these machines bigger, we can make many machines. It's really easy to build a scalable client comparing to a scalable server. So that's number 3, and the client will not see that. Again, it's really like the whole burden of scalability actually is now on the shoulders of the messaging platform. So if we have 1 million clients, then they will all be connected to the messaging platform, and the messaging platform has to be strong enough. It has to be something big, like I'm saying, the Slack or something like that, big company, which is not a problem now. We have these companies now. Well, we had IRC before, where it was like, I don't know, it's on the market for I don't know how many years, maybe longer than I am. So, but it was before like that. But now we have commercial solutions which can handle a lot of traffic, and they will basically not be against you talking through them. So Slack, you just connect to them, and they will allow you to put all your customers on these discussion channels. So the scalability problem is kind of gone in this case, because it's not completely gone. You still need to think about how to parallel your service, how to make them work in parallel, but it's now way easier to make it scalable. This is number 3, I believe, right? Yeah, that was number 3. This is number 4. In total, there are 6, so we are in the middle. Number 4, the bugs are not visible, which means that people will not see, users will not see the problems, the defects of your microservice as often, and they will not complain as critically as if they would use them through the browser. In the browser, when the user sees a stack trace, it means that the server is down and the user will complain, they will tweet about it. It's really like serious consequences, because it will visually show to the user that there is a problem. Because they expect you to answer immediately, they expect you to have no bugs, they expect you to be really reliable in order for them to use you. In our design, when it's a client, then the bugs are, I just know it for the year and a half of work of our service. We have bugs. We have them every second week or something. Sometimes something goes wrong, but in most cases people just don't see them. They just don't know that there is a bug. If they post a message on the chat, for example, and we start answering not in 5 seconds as usually, but in 5 minutes, they don't really care that much. Some of them may complain and say, I just noticed that you're too slow for some reason. That's it. But maybe there could be a serious problem on the server. Maybe the server is extremely slow for some serious reason. But the user don't know that. The user don't see this. So the bugs become less visible. That's my point. So people just don't see that something goes wrong. That's the benefit of the chatbot in general, I believe. I don't know other chatbots, like how they work and how their designers feel this benefit or not, but I do. So I'm the architect of the solution, so I monitor the solution, I see the logs, I see the servers, how much memory and everything and CPU they consume, and I understand, and I have this, the errors and stack traces in my logs, but the users complain extremely, well, not really often. Like sometimes when something really goes wrong and we just stop answering. When the bot stops answering, then yes, the user will complain, and in half an hour, in an hour, they will say something is wrong, I was expecting an answer, and for half an hour there's not an answer, for example. Or I'm giving a request and something coming back which is not the answer I was expecting. But the majority of problems, especially minor problems, they're just not visible. So that is the number, I think number 4 or number 5. Yeah, it's number 4. So the bugs are not visible, which gives me as an architect a lot of flexibility in actually making changes to the solution. So I'm not really afraid that much of breaking production, which is a typical fear for architects and people who develop something live. In this case, it's not really that critical because I don't have the traffic which is coming in, which is a typical situation where the web service is expected to be online full time and online answering whatever comes in. In this case, I have some delay in answering. I can't wait for a few minutes. If something goes wrong, I still have a few minutes, maybe a few hours to fix stuff and then still put it online. Most of the people will not just see the problem. Most people will not recognize that something goes wrong. That is number 4. Number 5, the benefit, what it gives me as an architect of this solution. Everything that is happening is traceable. Because we're talking through a messaging platform, we're talking through some messaging system, then all requests and all responses from this service, from this web server, microservice, everything we can trace back and see how it happened for, I don't know, a year back. Which is, and you will see how people were talking to this microservice and how microservice was replying back. This is something you cannot get if your microservice is an HTTP endpoint or a web page. You can design some logs. You can make them really powerful. You can put a lot of information in the logs. But how much time and money will that cost you to trace everything, and how transparent it will be for
My apologies.
Yeah.
I might have came in late. But is your microservice pushing data to your IRC channel?
Yes, that's right.
Is it just pushing arbitrary data?
Not arbitrary. It answers your requests. So you post questions, it answers your questions.
Well, then isn't the message bus, essentially what you're trying to describe in the middle, isn't that actually requesting information from the microservice?
No, it's not requesting. That's the point. So this central place, which is a message hub, it's not requesting the data. The microservice is just listening to, like, connecting every minute or every few seconds and checking, do you have something for me? Do you have some new information for me? Do you have some requests for me? So the microservice is acting as a client, not a server. So the HTTP connection is happening from here to there, not the way back. So not the Slack is connecting to me, I'm connecting to Slack and saying, do you have something new for me in these rooms? But I'm not using Slack, I'm using GitHub. So in GitHub, I'm connecting to GitHub every minute and I'm checking, do you have some new notifications for me? This is the API of GitHub. And GitHub says, yes, we have 3 new messages for you. And then, I say, this message I give answer here, and answer there, that's it. Then I connect again in a minute and say, do you have something new for me? So the GitHub doesn't know about me. The GitHub doesn't come back to me. I connect to GitHub and I check what's new for me. So it's like a mailbox for me, basically. So I'm just checking the mailbox. Do you have some mail for me? Do you have some requests? And I post some information on there back. So we are communicating like through the mailbox or some messaging. I'll show it like in practice, so you will see technically how it works. But here the point is that we have the log. If it's GitHub, it's a ticket in the GitHub. You probably know how GitHub works. They have ticketing systems. So there's a ticket. In this ticket, the user posts something, and then the service posts something else, and then the user posts something else, and then we have this conversation which stays there forever. We can get back to this conversation in a year, and we will still see this whole, it will be completely transparent and traceable for us. We will understand why this happened and what exactly happened. We don't need logs for that. I mean, we also keep some logs, but these logs just get destroyed like every month because we keep logs for basically for security or debug purposes or something like that, for technical reasons. But this log is for understanding how our microservice was used. So I'm talking about microservices which are not, which are not time critical, and we cannot implement like that a microservice which is supposed to give you some information in really milliseconds. But these microservices are not, well, it's a different category. I'm talking about services online where people can actually wait for a little bit. In that case, this whole presentation makes sense. So the traceability is important. For me, it was really important because I can see how people communicate with the system, what they say, what the answers are, what the problems are, which I can implement this whole thing myself inside the microservice. I can make these communications inside. But in this case, I will just replicate the GitHub inside my solution. I will basically copy the functionality of GitHub or of Slack. So this login feature, logout feature, restore the password, give me the email notifications, formatting of the requests, how to render them online. That's a lot of functionality which is already implemented by GitHub or by Slack or by other messaging platforms. So why making it a game for us, internally, to basically to duplicate this functionality? It's better to reuse these public services like GitHub or Slack and reuse this functionality, which gives us the traceability, which is really important. So seeing the log is an important thing, and I call it traceability. And the last one, the last benefit, number 6, it's easy to integrate, which is probably the most interesting benefit, maybe not like very practical from the first sight, but what's interesting here is that if you design your service, your microservice or service or web service, whatever, if you design it that way, like a chatbot, you will be able to integrate it with other chatbots. And they will start talking to each other. Not only people will talk to chatbots, but chatbots will talk to chatbots. So I design my chatbot will understand this amount of commands. You design something else which understands another set of commands. And then we can start talking to each other without being connected through RESTful APIs or JSON requests or XML requests. We're just going to talk the way that people will understand us. So the users will be able to see how these chatbots communicate to each other to perform some real task and to do something in reality. That will be the final, that's the final goal of this whole approach, I think. That the era of chatbots is coming, I think, and we will have more and more of them. And eventually they will start communicating to each other. And people will start designing their systems as chatbots or as chatbots who will understand other chatbots. Maybe there will be some language for that, maybe there will be some standards for that, I don't know, that's for the future. But now I see that we have this, we have that. In our business, we have not just one chatbot, we have a few other chatbots which help us in different tasks. I'm not going to describe them now, but I'm saying that we do have this solution a little bit. We're starting to do that. So we have a number of chatbots and they start talking to each other. And why it's so beautiful, why it's so interesting, it's a little bit slower, of course, because this message by message, it takes more time than instead of they would just make JSON requests to each other and just get an immediate answer. But it gives all the previous 5 benefits to us. It's easier to design, it's traceable, it doesn't need the time to design the interface. It gives us all of these benefits, and we have the solution which is extremely scalable. So that's basically number 6, and I want to know what you think. And then I'll show you the practical example of how it works. And then we'll have questions. And then you can follow me on Twitter, on Facebook, and GitHub. So what do you think?
I don't know that it's a replacement for a UI, but I could see how it would be really handy for APIs that don't have UIs. So maybe something that another microservice or a service bus would call. So if you need to check to see if it's up or you need to get data out of it, then it would be nice just to be able to hit it from Slack or GitHub or whatever you wanted to.
Yeah, I wouldn't say, yeah, like, that's right. I wouldn't say it's a replacement for like I wouldn't say it's a replacement for all web services, for all microservices. Like I said, there are microservices, let's say DynamoDB. It's a microservice. We can call it that way. It's the microservice from Amazon, AWS. It promises a response in less than 10 milliseconds. So definitely this chatbot approach is not the way to do it. But at the same time, the Amazon, the DynamoDB, they have a console, so-called. When you go there, and then in that console, you click the buttons, you manage your tables, you see what's going on. And this console, now it's more powerful. But it took them, I don't know, 3, 4, maybe 5 years to make it really look more or less acceptable. And how much money? In the beginning, it was horrible. It was difficult to do anything with these tables. It was difficult to manage. And they did it they did it through the UI instead of making a bot. If they would make it possible for me to talk to this DynamoDB web service through some chatting, through some chat panel, I would immediately get the full functionality out of it. They didn't have that. It wasn't possible to do certain things through the UI for a few months or a few years. I was one of the first users of DynamoDB. And at the beginning, few years, it was a nightmare. It was difficult to work through the console because some operations were just not available, or they were not just perfectly designed. It was difficult to understand how to do it there. So if they would introduce a chatbot for the management of the DynamoDB, like create table, drop table, check how many lines are in the table, check the performance of the table, all these kind of requests, that would be easier for them and for us as programmers, to communicate with them. Of course, there's a certain part of DynamoDB which needs to be fast, extremely fast. In that case, yes, it's a microservice, traditional approach, but there is no UI there. It's just a JSON/XML endpoint where you connect and get an answer. But when we're talking about UI, especially for services for programmers, I'm not talking about Airbnb. Airbnb should have an interface, and people will not just chat with the Airbnb because they're not programmers. But if the service is for programmers, is for technical people, for architects, then building a nice looking UI will take like 90% of your budget. And then the 10% you will just spend on real actual service. Like in our case, I'll show you right now our case, and you will see that if I would create a UI, I would spend like 90% of my time and effort and money just to build a UI instead of doing the real server optimization and Docker containers and really doing what the service has to do for the end users. So, yeah.
Do you see this as an alternative to REST APIs on microservices?
I think they should go together. So the REST API is something, like I said, for the DynamoDB, for example, as an example, it has to be there if you need to give like instant, immediate answers to some certain things. If your web service is about restful answers. But for the UI, yeah.
I think that it would be very helpful for you when you're explaining this to have a different set of terminology to make sure that you can differentiate between the things that you're talking about. Because I think in a lot of people's minds, especially developers, when they think microservice, they think I can connect this thing with HTTP, with send JSON, I can post it. They're thinking about the HTTP capabilities as being a definitive part of microservices, and you have a broader view of what this is. You're thinking of them in terms of how can I service an action that somebody requires. And so I think that there's an implementation level disconnect with a lot of people. And if you came up with a different terminology, or if you were very clear about your terminology early on, you might be able to, this presentation might go a lot smoother.
Okay.
I understand what you're talking about. I've been doing this for several years now, in fact, exactly the same thing you're doing. But I was using Jira instead of GitHub. But this concept is it has a little disconnect with people when you're talking about microservices.
I would certainly disagree with that because the product I work on has a bunch of microservices. They're really tiny components that basically handle one kind of request, but they're not RESTful at all. They receive messages from queues and post a response back on a different queue. It's all queue-based. We post things to Rabbit.
So people call microservices different things.
Yeah.
So yeah, that's right. That's right.
But I understand. I kind of see where he's coming from.
Yeah.
That's the sort of the common.
So probably the definition of what I mean by microservice would be helpful. Yeah, that's right. That's right. I agree.
Do you see this as an alternative to something like RabbitQs or?
Oh yeah, definitely, definitely. I think that's a good thing to show to say that this is an alternative. So all this RabbitQ and all that stuff, which is, or also in Amazon they have AskQS, also the service for queuing. This is definitely would be way easier to do it that way, because in that case people can understand it as well. You can jump into the conversation and see how your chatbots are talking to each other. Instead of in this RabbitQ, it's difficult really. It's JSON messages there, XML messages. You need to be really like technical person, really have your everything in your fingertips in order to understand what's going on there. Here you can just don't need to be really special technical. You just jump into the conversation and see how these bots are talking to each other, or people talking to bots. So definitely a replacement for queuing services like RabbitMQ or hosted one, the AWS SQS. That's definitely a solution. Well, I would definitely, if I would design something new now, and somebody would ask me like how we do it, definitely as a chatbot in some, maybe not in Slack, maybe in IRC, because it's really like way more technical and probably cheaper than for massive. If you have like a huge amount of messages, then use something like IRC, because I think it's more scalable than Slack and GitHub for sure. But GitHub, it's perfect for people because it's easy to log in there. They manage everything for you. Restore email, upload your picture, format your message. Everything is done there. Our code is small and their code is huge. But in the end, the users, they use both. They just experience GitHub plus us. And let me show you how it works. So this is the service I'm talking about. It's called Rulter. You can check it. It has a web page, but this web page is just one page which says, "Hey, we're online, we're alive." So you cannot through the web page. If you go there, you just see the logo. You see some icons there saying that yes, it works. We just online. So the bot is working. The bot is talking to the GitHub. But that's it. And now let me show you how it works in practice. Go in here. So this is. Do you see that?
Yes, it's a little tiny dark.
Yeah, a little dark. So this is basically, you won't understand. So this is basically a GitHub. It's a small project, open source project of myself. And this is a pull request. So it's a pull request. So what this Rulter system is doing, the Rulter is helping us to merge pull requests using Docker containers. So when somebody submits a pull request to our project, before we get this pull request, and instead of clicking this button merge, which is here. So there's a button called merge. So you can call merge and the GitHub will just, probably you know how it works. And the GitHub will just merge your stuff into master branch. Instead of doing that, we just created this system which helps us to, before doing the actual merge, the system put together the branch and the master branch inside the Docker container, runs the full build. And if it doesn't break, then the merge happens. So basically, when the pull request comes in, we need to initiate this whole process. We need to tell somebody like, hey, start a machine, start a Docker container, get this code in there, get the master branch, put them together, run it for, I don't know, half an hour. When it's done, click the merge button and report back to us. This is the service which worked for us. So this is what it does. And it talks on GitHub. If I say here, for example, I say Rulter, you don't see it, but Rulter, for example, I say hello. So I just posted a message to GitHub. I said Rulter hello. That's all. So I don't have any control panel. I don't have any. I didn't configure anything. It's just a public bot which is listening. You see, there's a pull request. It's a public bot which is listening to all conversations on GitHub which are happening in its name. So if somebody is talking to Rulter anywhere, then when the message is there, it connects to GitHub every minute and checks, do you have anything new for me in all tickets across the entire GitHub? You can try it yourself. You can post the same message in your own project, and you will see what happens. So you see, it takes some time. So it's not immediately. It takes some time. We're just waiting. We're expecting the bot to answer. And every minute it checks what's going on GitHub, on the entire GitHub. And the GitHub informs the bot about the situation, informs about, boom, we just got an answer. We just got an answer which says, it talks to me, hi there, I understand a few simple commands, this and that. This page explains them briefly. Any questions or bug reports, submit them there. Have fun. So it does talk to me. It's alive. I can say something else. So the beauty is that, look, we don't have control panel. I didn't log in anywhere. I didn't create an account in this system, in this router. It just hosted somewhere. It's connected to GitHub, to the big messaging platform. It talks on this messaging platform to me when I say something there, and it can do something for me. Let's say I say, router, do something for me. So it does understand a limited amount of commands, and this is definitely not something that this bot will understand. So now it will talk back to me and say, I don't understand that. So give me something more meaningful. And then I'll show you, then I'll give you a meaningful command. I will tell router to merge this request, like I just explained, to start a machine, to start a Docker container inside the machine, run the full build, boom. You see, it says, I'm sorry, I don't understand you, check this page and try again, please. So it's a simple chatbot which understands just a few commands, which you can try yourself. You can just create a project in GitHub or use existing project in any ticket, post a message like that, and you will see an answer. Without, like I'm saying, without creating an account, without going anywhere and making uploading your email and starting this whole process. You just get answers. And there's no user interface, like you see. So you don't know how this router bot looks. It just talks to you. It just answers your questions. It just does something for you. Let's ask this machine.
How is it pushing the info back to the browser?
How the what?
How is it pushing the info back to the browser?
It's done by GitHub. I don't know how they do. Well, JavaScript probably. Yeah, it's done by them. So we don't care about that. We just get the question and post an answer. And they do all this whole thing, this entire interface. It's GitHub. It's not mine. You see, it's a big company. They do it for programmers. They a multi-million-dollar company, and we just use their service instead of re-implementing it ourselves. Instead of making this chatting functionality on our side, we just use them. So let's ask this dude to merge this pull request. I'm saying router merge. It's one of the commands which it understands. So now I think it will start this process, like I said. It will start a server, start this Docker container, and start doing something there. Again, behind the scene. So I can't see it. I can't open any web page which will show you the progress, but it's gonna be here in the chat mode. So we will be talking to this bot. It could be, like I'm saying, it could be another messaging platform. I don't know so many of them which look good and really popular for programmers. We just develop all our projects on GitHub, and that's why it's easier for us to integrate. But, for example, Jira or any other ticketing system would also be a good candidate for integration of this bot. And now we're thinking about integrating this with GitLab or maybe with Bitbucket. So that's going to be the future. It's the same machine, the same server, the same microservice or whatever, but it will just start talking to a different server. You see, it said, okay, I'll try to merge now. You can check the progress of the merge here. So if I click here, it's going to be a new web page, and on that web page, I'll just see the log of what's going on, just the plain text. This is the only web page of the router. And now something is happening. So we can see it in action. We can't see any running progress bars or whatever, but we can say, for example, router status. So I can ask it to report me back, what's the status, what's going on now? You just started the merge, I want to know what's going on. So I say status. Again, it will take some time because we're checking GitHub every minute, not every second, every minute. Mostly because the GitHub doesn't really allow us to check every second. So, well, it will complain if we do too many requests to GitHub. So I'm saying, show me the status. And the answer will be, again, it will be, it's not the interface, it's going to be just text message, but it will be quite informative to tell me what's going on and why it's going on. What was I talking about? Yeah, so I don't know many other, that popular chat systems or messaging systems. I believe in Slack it's possible to do, but GitHub is good. Why GitHub is good? Because we have the code over there, and our solution, this router, is basically a tool for working with the source code. So it's a perfect integration of where this code is, and you see, we get a message. It says, okay, this is the status. It says, this is what's going on here. And then it gives me some information. like I'm working on this fork, I'm merging 60 seconds already. The Docker container is this, so it's the name of a Docker container, some side of the work directory, a server load average. So it gives me some information back, some details of what's going on. I can see it online, I can see it on a web page, I can see the progress over there, but I can see it in this simple text message which comes back to me. And then in about, it should take, I don't know, maybe 4 minutes, maybe less, this merge will be completed, and we will see the message here. It will be again posted here, boom. The pull request merged, so now it happened. So the router, the machine clicked the button, so the merge request was merged, and now we should see, again, probably in a minute, we'll see a message saying, I'm done, you can go there and see the logs. So the point here is that we are very much decoupled from the actual machines. You probably see it yourself. So we're just talking to something and we don't experience, we don't feel that there is something big is happening in the background. Because it's for us, it's just like messaging. We don't have the UI. Yeah, so now it's the last message. It says, done for your information, the full log is here. We can click here, for example, and see the full log. So this is what it was doing, like all the commands, it was the full build of, well, for people who know what they were going to do, it's a Maven build. So it's a Java project, so that was the Maven build. Unit tests, we executed some unit tests. It was a full run of the Maven build. And in the end, it was git, commit, push, region master, so boom. So the full cycle. Got the pull request, got the master, put on top of got the branch, put on top of the master, run the full build, check the result is good, build is successful, build success, and then it does all the manipulations which need to be done when the merge is happening, and then it's done. So that's basically, that's what I wanted you to see, and let me. Yeah, so now are your questions and I'm done.
Did
Yeah.
you use a pre-built Docker container or did you build that on the fly?
We build on fly. Yeah, we have an image. We have an image for Docker. Yeah, of course. We have an image where we start from, but for each project we have like custom, or it's a custom container where, yeah.
Is it maintaining the context of the conversation with you while you're on that page?
Yeah, absolutely. The GitHub does that. Yeah. Oh, you mean the context of, okay, what's the status of, yeah, of course, we use DynamoDB for that, yeah. So we keep this information.
So because you made a request, it blindly went and did it, and then you asked it its status. So it knows that it's having a conversation with you essentially.
That's right, yes.
It's keeping track of that. It's
Yes.
keeping state of that
Yep.
conversation somewhere.
Yep, exactly. Well, in our case, that's important because we want to keep this information because we started for you just a container, so we need to know what is the container, so we need to save it somewhere. So we attach the number of the ticket we're talking in and the location of your build and everything what's happening. So we need to keep this information persistent. But in some other cases, maybe it's not necessary. Maybe you don't need that in your specific examples. Maybe you just answer answer questions. I mean, one by one, and that's it. So you don't need to keep you don't need to keep state. You don't need to remember state. But in our case, yes, we do remember state. We have, like I'm saying, we're using DynamoDB for storing this data, and for any other, yeah.
So you're using GitHub to deal with the authentication. What about authorization? Can anybody give it a merge command?
For the authorization, first of all, we know who made the request because GitHub gives us this information. So we know that GitHub already authorized you and we know your name. That's first. So we trust GitHub on that. That's first. Second, when we configure the project, in the project we let our users who use this router. This is a public service, like it's like just understood. So we give it to everybody. It's free, and we have, like I said, probably now about 300 users. 300 projects are using router on a regular basis. And when the command comes to us, we just know who sent the command. We know the GitHub that gives this information. And then inside the repository, we keep the configuration file in YAML, like Travis does. We do the same. So it's a configuration file where you, as an owner of repository, can say, like, I'm accepting requests only from these 5 people. And in that case, Routel will tell you, like, sorry, no, we're not gonna accept from you. You need to ask that person to help you. So it's configurable.
If 2 users who have rights to do the merge send a message at about the same time, what does Router do?
Yeah, the first one. We just go first in, first out.
Well, the first one goes, then the second one hits and says.
The second one, the first one goes, if the merge happens.
The whole thing.
If we just post the merge again to the same pull request, the router will say it's already merged. Sorry about that.
So it's a synchronous process.
Yeah, it's
You're not
sequential.
gonna
Yeah,
take
it's
the next
sequential.
message.
Yes, the first in, first out. So we just keep the line. We keep them in a line in the queue, and we answer requests. Who comes first? We just answer the request. That's specific for this project. In a different project, it may be different. You may accept parallel requests, and like I say, these bots can start talking to each other in parallel. But in our case, it's important to keep them in a line, one by one. So that's why we did it that way. So, any other ideas, suggestions, comments, complaints?
So you actually do have a user interface, and that's the message that's coming back from Realtor?
Yeah.
Because if you mess up, if you got typos in there, if it doesn't make sense, people are gonna say, what's wrong with you people?
Yeah,
You still have a user interface. It's a lot easier than doing a nice pretty one.
Yeah, we don't have like user interface, but we have help pages. So when you say something which we don't understand, the routers say, I don't understand you, here's the web page, HTML page for you to learn more about the commands I understand. So that's it, like I was expecting that question. So what kind of commands and what kind of language this chatbot would accept? In our case, we just defined maybe 10 commands and that's it. And it's pretty simple. If this keyword is in the text, we just do what you say. So you can say merge, or you can say please merge, or you can say merge me please, or please merge this. It doesn't matter. If the merge stays there, then it's the merge command. There are many, we can say like status, merge, deploy, release. We basically support 3 commands: deploy, release, and merge. That's how we automate the entire DevOps operations for all our projects. So this is really simple syntax. We don't do any we don't do any syntax analysis of your text, or we don't do any artificial intelligence to understand what you actually meant. We're just looking for keywords and that's it. But maybe in other situations, you may design your chatbot more powerful and it will understand the semantics more deeper and more powerful. But in our case, that was just enough, just a few words. If we don't understand you, Router just points you out to the help page, and then you go there, you learn. That's what people usually do. So they don't ask me. So nobody is sending me now. Well, we had that a year and a half ago when we just started and we didn't have these help pages. People were just saying like, I don't understand how this thing works, because where's the UI, where's the front end, what do I click? But when they start saying something, and we made this interface more and more powerful, the interface started to give answers better and better using these help pages, and now I don't have any requests from anybody for maybe 8 months or so. So nobody is asking me how this thing works, because they just say Router hello, and there is a boom, an answer which says this is the help page. They start from there. They say something else. Router says no, I don't understand you. They learn on the fly. They learn on the go, and in a few attempts, they know how it works without the UI. Yeah.
What are some of the other chatbots that you're working on? You mentioned you're working on some other.
Yeah, we have a few, but we use them internally. And for example, when people, we do software development. We're a custom software development company. And people come to us, programmers come to us every day. 5 up to 10 people, submit their resumes, because we work remotely, completely remotely. We work with freelancers only, and people come to us because they want to work with us as freelancers. And they submit, we have a form, so they submit the information about please interview me, start working with me. And then we have, they jump into our own, we designed, a similar to GitHub, but way more primitive system and more suitable for us, also this conversation system. And they jump into their form is just dropped in there, and then the bot is invited, and the bot decides, okay, who's gonna interview this person, and it invites another person to interview, and then when the interview is done, the bot says, okay, thank you for the interview, it processes this information. So we basically let our candidates talk to our bot before we hire them. So that's another application. It's kind of funny. Again, people, sometimes they don't understand it's a bot, and they start talking to it, and the bot says, I don't understand you, I'm a bot, sorry, and they're okay. And what do you understand? So it's really, because they don't understand, we made this bot, we made it as a girl picture, and they don't realize that there's actually a bot talking to them. So when they start the conversation, they sometimes get confused, which is fun. But in the end, they realize that everything goes smoothly, because they understand that you can give a command, you get an answer, so you don't need to wait, everything is organized and disciplined, like in this case. So there's no human involved. And well, but that's our business application. It's more, but that's an example of how these bots can be used for. Basically, I think the future for them is to integrate people and computers. So people will be integrated in a more intuitive for us way. So user interfaces, I think, are not that intuitive for business operations as talking to somebody, but as just typing and saying what you want, instead of looking on the screen and trying to figure out what are the buttons, what do I need to click, and how do I need to understand the language of the computer? Because all these buttons and forms and clicks, these are the language of the computer. The real language of me as a user is the English. So I'm saying what I want. I'm saying, hey, do this for me, or I don't know, hire me, or how about increasing my rate, or how about signing a contract with me? Can you send me the contract? Boom, you got a contract. How about you show me what are the conditions on which you can increase my salary? Boom, these are the conditions. Okay, let me try that. Okay, so somebody's talking to you instead of you figuring out how to fill the form. I think in general that's the future, I believe. And this is the first step. I mean, the first step we've done. So I'm done. If you have any more questions, you can come to me. I'll give you my card, subscribe to my blog, read my articles. It's all on the blog, and you can find out more. Thanks for coming.